All right. Good morning, everyone, and welcome to the December 2022 Argo CD and Rollouts community meeting. I'm your host for today, Jesse, maintainer of the Argo project. If you haven't already, please go ahead and add yourself to the attendee list on our meeting notes. And just a reminder that the Argo project adheres to the CNCF Code of Conduct. So please be courteous and respectful to one another. And this meeting is being recorded and will be uploaded to YouTube later. If you have any agenda items, issues, or discussion topics, you can also tack that on to the meeting notes and we might be able to get to it at the end. And today we have actually a number of topics. Then we have Keptn maintainers to talk about GitOps with the Keptn lifecycle controller, some Argo CD 2.6 demos of new features, and looks like a project called Iterate from Alan. And before we get to that, actually, if you didn't hear the news, Argo is officially a graduated CNCF project. So this is actually a huge milestone that everyone should be really proud of. And, you know, we're up there with all these big names like Prometheus and Kubernetes itself and Envoy. So first, like, thanks to our maintainers in their community for all the work, you know, documentation, fixes, and just even just using the product itself. All that feedback is what got us where we are today. So thank you for that. And I don't see Henrik, but especially I wanted to give some thanks to Henrik, who's been kind of just driving this graduation process. So he deserves a lot of credit for driving this. Okay, with that, let's start with our first topic of today, which is extending GitOps with the Keptn lifecycle controller. And we have Thomas Schultz here. I hope I didn't
yes, hello.
butcher that name. Okay. Do you want to?
Yes, I would like to share my screen. I hope anyone can see my screen.
We can.
Yes, so at first, thanks for having me here. And we from the Keptn team also want to say congrats to the Argo project and the community for the graduation. We are not so far at the moment, but hopefully this will also happen sometime. And during the last few months and years, we made many efforts to integrate Keptn in GitOps in Keptn and so on. We also found out all of the time that it's hard to integrate workflow, so pipelines and context-related things into GitOps. And with these things, we started to develop something completely new, and this was the birth of the Keptn Lifecycle Toolkit. My name is Thomas Schütz. I'm a maintainer of Keptn and working for Dynatrace. And I think this presentation will take about 20 to 25 minutes. So at first, let's take a look on what we found, what's cool about GitOps. So at first, we have a declarative state in a versioned way. So we have everything we want in a Git repository. We have it versioned and can apply it whenever we want. Things we apply there are reconciled automatically. I think I don't have to tell this to you, so you might know this the best. We have a single source of truth for everything we want to apply. And in the end, for us, it feels like, and it is the natural way to deliver apps in Kubernetes. So I think the previous graduations in the cloud native space proved that this is the way to go today. But sometimes also with GitOps, some things get complicated. And at first, when we are thinking of GitOps, most of the time, so I know that there is that you can suppress autosync in Argo and so on. But Normally, when you push something to Git, it gets applied, and that's good in this way. But in larger scale, it's sometimes nice to know if the infrastructure is ready for this deployment. So for instance, am I already troubleshooting on a namespace or whatever? And is it okay for me to deploy the newer version? The second thing, are there some prerequisites for this deployment? So for instance, do I need some infrastructure related to this before I apply the configuration? Then sometimes, and this is also nice in Argo, you see graphically many things very nice, but often you really don't know what's happening at the moment. So you don't know how many deployments are running on how many clusters and so on. And last but not least, after you deploy the application, you only know that it's technically correct. So you know that you have the specified amount of pods, you know that your health checks are ready and so on. But in fact, you don't know if your customer clicks on a button, if it takes him about 1 minute to get to a response. And these are the things we are trying to tackle with the Keptn lifecycle toolkit. So the first thing we tackled and what we are doing at the moment is we are trying to build in observability into the deployment process. So you can think of the Keptn lifecycle toolkit as a controller which is running in the Kubernetes cluster, and which tracks your deployment process and also do some measures to add tasks, run evaluations, and so on during the deployment process. For observability, we are adding some metrics to the deployment things, such as the success rate of deployments. We are tracking some velocity-related things, and you also get the current state of your deployments. What you see on the in the picture here is this is a simple Grafana dashboard, and you can use whatever solution you want because we are exposing the metrics using OpenTelemetry, and therefore whatever backend you're using, you can display as you want. The second nice part we are doing here is we are building traces out of the deployment. So for instance, you can define some kind of applications which can consist of multiple workloads. And in the end, you see how your application got deployed, how long your pre-deployment tasks took, how long your post-deployment tasks took, how long the deployment itself took. And you can start to troubleshoot there if on the performance. And as you see here, you can also see you can also see where in your deployment the problems came up. And all of the things we are doing here are working out of the box. So you don't have to specify special custom resources to get your deployments in there. So we are using deployment stateful sets, daemon sets, and so on, using the Kubernetes recommended labels. For some things, such as applications in our case, which is a bundle of multiple workloads, you need a custom resource because there is none in Kubernetes at the moment. And also for evaluations and tasks, you also need a custom resource. But everything we are doing here can be specified in Git, as we will see afterwards. And you can simply apply this via your GitOps tool of choice, via your pipeline tool, and it will work. The second thing we have are pre- and post-deployment tasks as well as evaluations. And therefore, you can, as I said before, you can, for us, it's not really relevant which tooling you are using because we are working on the Kubernetes cluster itself. So for us, it's okay to use Argo, you can use Flux, you can use Jenkins, whatever you like, as long as it deploys to Kubernetes in the end. When it comes to Kubernetes, we can do some pre-deployment tasks based on the application level. So such things as checking for error budgets, checking for infrastructure readiness, running preparation tasks. These are all things we can also do on a workload level. We did this at the moment using custom functions. So you can write whatever Dino code you like. This can be executed in our controller, and if the scripts ran through, the next stage will happen. Okay, and after some time, all of the tasks are ready. Kubernetes did its work and scheduled the pods. And after each workload, you can run some kind of post-deployment tasks as well as evaluations. And after all of the workloads of one application have finished, you can also run post-deployment tasks and evaluations based on the application. What you see on the right lower side is such a typical evaluation definition. In our case, we use Prometheus. We specified one objective, and we did a PromQL query. In the future, it will be possible to do this with whatever observability provider you like, whomever created a provider for Keptn. Okay, so I think I talked very much now, and I think you might want to know how this works. I will demonstrate this based on a demo application. So I took the potato head, the demo application of the tag app delivery. And in our case, what I want to demonstrate is I have an application with 6 services, and all of the other services only get deployed after the entry service has been finished. In this demonstration, this will change a bit. I will use Argo for deploying. We will do some pre-deployment evaluation and check if enough CPU is available to run this. So for this, we will utilize Prometheus. After we found out that this is that there is enough, then we will run some pre-deployment tasks and check if the entry service is available. And in the end, we would send out the Slack notification. This is the thing I dropped today. Okay, so then let's get directly in the demo. So I have a sample application here. And if we take a simple look on the manifest here, we see that this is a typical manifest as we know it from Kubernetes. So we have a namespace. The only thing we had to do to enable the lifecycle toolkit is we had to annotate the namespace. Then we have some kind of deployment. And in some deployments, we might also see a part of label, which is in our case specifying to which application this workload belongs. We have a name label. This tells us that the workload is named this way. And we added some Keptn annotations where we can say, yes, we want to run a pre-deployment task. The same would be for post-deployment tasks and for post-deployment evaluations. If we want to see how such a pre-deployment task looks like, then we will have such thing, hopefully. Let's take this one. So this is, yes, yet another task definition. We defined how it's named here. We defined that where it is deployed to, and we can specify where we can find this task. This can be either an HTTP server. So I will simply open this and can show this to you. So in this case, this is a very simple TypeScript function where you see where you simply fetch an URL, and if it is okay, then we exit with 0, and otherwise we exit with 1. So a poor man's dependency check. But this can also be more sophisticated things. So we did the same with Slack notifications. You can run promotion tasks and whatever. And you can parameterize this, and with this I only said, yes, I want to check for this URL, and if this is there, then it can run. So this was a typical pre-deployment, was a typical Keptn task definition. The second thing I told you before is that we know the concept of an application. So for instance, we could say we have an application which is defined as this. This is a Keptn app. This is called the potato head. This is in the version 0.10. And this consists of these workloads in these versions. And the funny part is before, without these definition, if you want to use apps, Keptn will hold back the application until this state is until this definition is there, and until a definition is there which utilizes the workload. And you can also run pre-deployment evaluations, pre-deployment tasks, post-deployment evaluations, post-deployment tasks based on this application. So before the first workload got deployed and after the last workload got deployed. Okay, so let's simply apply this. And in my case, I prepared some kind of configuration. And this is a thing, a typical Argo manifest. So I said I have an application which is called Potato Head. This is the repository, and I have my customized configuration here. So let's simply apply this. And in my Argo UI, I should see now the thing. And what I should also see is that my pods stay in a pending state now. So what's happening now is that I have I can take a look here. Get Keptn version. I have my Keptn application here, where I can see, yes, this is currently in the pre-deployment evaluation phase. And in this case, I have what I also see on the pod level is pods and sorry, this was the wrong one. I see that all of my workloads are pending because the pre-deployment evaluations have not been finished until now. And after some time, I should also see that they fail. Sorry. Yes, I see that the pre-deployment evaluation now failed. This was in this case because of some thresholds were set really strict. We can also take a closer look, and this is the interesting observability part in there. We have Grafana dashboards for that. We would see that our application is running at the moment. We see that 5 of our applications were failed. And the nice thing is we can also take a closer look into our deployment and see that we had a deployment for the Potato Head in the version 1.0.1. We had some application pre-deployment tasks which have been finished, but we had an application pre-deployment evaluation which has failed. And in the events here, we see why it failed. So we saw that the available CPUs were too few in this case. This will get prettier at some point in time, but I think you get the idea. Good. Now we can, in Argo, we would also see it progressing. So that's okay at the moment because the pods will not come up at the moment. What we are planning to do for Argo is that we are providing integrations where you see the state a bit more in detail. But we are in a pretty early state at the moment. Good. So let's get to a state where we can say our deployment will succeed now. In this case, I have a second version where I changed this. So I will simply use another customization. We'll do this one. And when I get back to Argo now, I should also see the Keptn application somewhere here. Yes, so I see the Potato Head 0.1.1 is also there. Now also, if I take a look at my application, so this can take a few seconds, I will see that one application deployment will get active. Yes, this is now. And I can see everything in my trace. So I see also that my pre-deployment evaluation has been finished now, and I will get a detailed trace of all of the workloads in the end. I don't want to wait now. I will show you one of the latest ones. Let's take this one. So this is the thing you see in the end. You see, for instance, you had an entry service. This was the one which has been finished at first. So you also see that all of the other services took longer. That's okay, because they were the entry service was a prerequisite for all of the other ones. And you can also find out where you lost time through all of the application deployments. And this is really nice. So, and in the end, after everything has been deployed, you could, for instance, say, yes, I want to send a Slack notification. This is the thing I do very often in my demos. Another thing which you can think of is that you can do some changes in Git afterwards. So with the TypeScript functions, everything is possible. But the nice part of this is you don't have a separate delivery pipeline before. You can run anything you would need to deliver your application, such as pre-tasks, post-tasks, and so on, directly in your Kubernetes cluster. You can also trigger external APIs and whatever you want. Okay, so what we will want to do in the future is we want to get more into the application health itself. So at the moment, as I said before, in Kubernetes, we are only knowing the technical state of the application, but we want to get more of a holistic view where we see the internal and the external state, so also the state of an observability platform in Kubernetes, and can take decisions based on that. We want to get to a point where our application state is actionable. So for instance, if a pod restarted the fifth time, then we could try to trigger a workflow, we could trigger a function or whatever you like. Another thing we could think of is also that we could try to switch traffic on the application state level, but this is a thing which comes in the future for us. Other things we are thinking, other use cases we are thinking of are some kind of Git promotions. So for instance, we could say this cluster has been finished. Let's change the Git repository or do whatever we want. Or if we find out that some post-deployment tasks are not finished, we can also flip feature flags to get back to a state where everything is okay. Okay, so what we heard today was with the Keptn lifecycle toolkit, you get more or less application-aware deployment. So at the moment, I know in Argo, you know some kind of concept of an application, but this is more a pointer to a Git repository or to a configuration. We get vendor-neutral observability, so you can use whatever observability backend you like, as long as it's compatible to OpenTelemetry, and I hope this will get more and more in the future. The integration of external tools is very easy. So for instance, we can write functions at the moment. On the other hand, you will be able to run containers in the future. And last but not least, the whole thing is very easy to install and configure. At the moment, we need two manifests. The one is Cert Manager because we're using a webhook. We are trying to get rid of this. The second one is our lifecycle toolkit itself. And you need some annotations for the configuration. Okay, that's it from my side. So if you find this is a nice project and you want to try it out, we are on GitHub. We are also a CNCF project, so you find us on the CNCF Slack. And yes, we are as this is a really new project, we are very eager to get to know about your opinions and how you see the whole thing. So if you think this is a nice thing and you think that something is not very could be done better, or you have ideas how to make this better, feel free to reach out. If you want, you can also contribute, raise up issues, and so on. I think as every open source project, we will accept. We are willing to accept many pull requests. And yes, as I said, you find us on the CNCF Slack. With this, thank you for having me here, and I'm not sure how it's used to work here.
Oh yeah, no, thank you for the presentation. So we had some questions that popped up in the chat. The first one was actually from me. I was wondering I also noticed the pods weren't starting. Is that, I was wondering the technical reason they weren't starting, was it because of a injected pod readiness gate that Keptn injected into the pod to prevent it, or why wasn't it becoming ready?
What we found out that the pods were annotated with some of our annotations, or with annotations we know. When we found this out, we injected a scheduler extension. So we are running a scheduler extension, and this scheduler extension takes care of our custom resources and tries to find out if everything is ready. And after everything was ready, then it bound the pods, and therefore then they ran. We know with Kubernetes 1.26 there is a feature for scheduling readiness, and this is a thing we plan to utilize in the future.
Interesting. I actually didn't know about the scheduler extensions. I assumed it was actually the pod readiness gate feature that is like a arbitrary string that you can put in, inject into a pod.
I think for the readiness gates, the pod has to run, and we want to avoid that the pod runs before we do as long as the things are not.
You're right. Okay. Yeah, so that's why you can't use readiness case. Okay.
So I think that's also the reason why the scheduling readiness probes or scheduling readiness feature has been developed. Because with this you can omit scheduling a pod.
Cool. I learned something new. Thank you. There's a couple more questions. First is, will it be possible to use other languages for tests, such as Go or Python?
Yes, if I have time enough, then it will be definitely possible to run tasks in Python, because I like to write. I like Python code more than the TypeScript code. And for Go, it's more about contributions. So when someone wants to create a runtime for this, then it also is not a real problem. I also think that it's not a real problem to implement this into our runtime.
Yeah. And the last question was if it is possible to have the functions in a Git repository. I saw it referencing a HTTP URL, but I guess the question is more about can it reference a Git repo instead?
Yes, at the moment you have three possibilities to reference to functions. The first one is you can define them inline in a custom resource. The second one is you can define them in a config map, which is in the background the same one as inline. And the third one is you can reference to an HTTP server. So yes, you can have the functions in a config map or in a custom resource.
One more question. So the demo showed the focus on the deployment, readiness, health, etc., on like a single environment. And the question is about, could this also be used to promote healthy apps to a next logical environment?
This is definitely a use case we want to cover, which we did not cover at the moment. So we started writing the lifecycle toolkit in the mid of September. But it is definitely a use case because we saw that this is asked by many people, and using such functions, I think this will be possible. It's only a matter of time until someone writes it, to be honest.
Okay, any more questions for Thomas? Okay, great. So Michael, I was going to propose that we actually let Alan from Iterate go next, and then just in case we run out of time, then we can save our 2.6 content for the next month's meeting just in case we run out of time.
Sure.
Okay.
Thank you.
Alan, is that okay with you?
Yeah, that's okay with me.
Okay, great.
Thank you for doing this.
Yeah. No, thank you for presenting. So go ahead and take it away.
Okay, sure. Let me see if I can share my screen and show some things. Oh, I have to go through some settings. Sorry, give me 1 second. Okay. Okay, I might not be able to show anything today, but I can still talk. So hello everyone, my name is Alan Chow, and joining with me today is also Sri and also Michael, and we are representing Iterate, which is an open source Kubernetes release optimizer for testing Kubernetes apps. So if I could share my screen, I will show you our website right now, which is
you could if you want to just quit
Okay.
Zoom and
Let me
join
try.
back. Yeah, I think it'll fix the issue. I had a question, Thomas, about Keptn. So I know Keptn's been around for some time, but you mentioned this was what you demoed was available since September. Like, I'm curious what was available before and with this, what you just demoed.
Yes, so before Keptn was a tool where we had where with very much use cases. So and it was often not clear what the positioning of Keptn is. And we also found out that it's very hard to integrate in GitOps toolings and so on. Therefore, we decided to build something new for such use cases. And this was the birth of the lifecycle toolkit.
Okay, is the previous Keptn is more like a classic one that will eventually phase out and then to replace with the
at the moment it's more the classic one. Yes, it is maintained, but the more recommended approach from now on will be the lifecycle toolkit.
Okay, great, thank
because
you.
it's more the cloud native approach for doing this, and and it's also easier for in terms of configuration.
Got it. Okay. All right, how's it going on?
Yeah, I am. Let me see. Zoom may not be able to record content, so I'm just screen until it is played. Okay, I think I need to do it again. I'm sorry.
Okay,
I'll be back.
yeah, no problem.
Okay, let's see if it works now.
Yeah.
Okay.
It's working, yeah.
Great. So again, I'll just restart. Hello, my name is Alan Chow, and joining with me today is Sri Parthasarathi and also Michael Kalantar. And today we're representing Iterate, which is an open source Kubernetes release optimizer for testing Kubernetes apps. And we're here today because we're working on a new feature that is built on top of Argo CD. And unfortunately, it is still in the works, so we cannot demo it today. But we want to share and have a discussion with you guys and see what you guys think about it. So in order to describe what we're working on, I need to first give some context on what Iterate is. So like I mentioned before, it is an open source Kubernetes release optimizer for testing Kubernetes apps. With Iterate, you can perform experiments, various kinds of experiments, such as SLO validation, canary tests, ABN tests, etc. And so in Iterate, what you do is you define an experiment, which is composed of various different tasks, and these tasks can do different kind of functionalities, such as waiting for services to start, collecting metrics from services, validating those metrics against SLOs, and you just need to list all the different tasks that you want to do and provide some parameters, and you're able to create these performance tests. So our latest feature is AutoX, and this is just a snippet of a blog article that I'm writing. I would not recommend reading this right now because you probably need the context from the rest of the article. But we do have like this little image that might be able to give you an idea of what's going on. But AutoX is short for automatic experimentation. And the idea is that Iterate can detect changes in the different Kubernetes apps that you're running. And based on those changes, it can automatically start new Iterate experiments. So for example, let's say you have a Kubernetes application and you just released a new version. You can set up AutoX so that it'll automatically start a validation tests for that new version. And you will be able to know if, the latest version of your application meets basic functional requirements, right? Making sure that it is performing well. It is meeting latency and error-related metrics, etc. And this feature is built on top of Argo CD. So in essence, with AutoX, there's a way to define what to watch for, what kind of Kubernetes resource should be used to trigger a new experiment, and which experiments should be run. And Argo CD is used to install these experiments, which are captured in Helm charts. And there's a few reasons why we chose to use Argo CD to do this. First, we're building the AutoX capability for GitOps users, specifically GitOps users that are already using Argo CD. And secondly, Iterate packages experiments as reusable Helm charts. So application manifests makes it easy to deploy these charts. So under the cover, we're using Argo CD as a mechanism for creating, updating, and deleting these experiments. So yeah, Shri and Michael, do you have anything else you'd like to add?
Well, we do have a demo that we're working on, and we hope to release to the community. Just a little bit more context in terms of who this is really intended for. So we have been working with a few other communities, especially machine learning communities like K-Serve, even the serverless Knative community. So we have a few users who are starting to use Iterate for ML deployments and experiments with ML models. And also Selden, which is a startup, machine learning startup, but they have their own open source Kubernetes resource types that they use for machine learning deployments. So we have when we talk about experiments, we're talking about performance experiments like load testing and performance testing, basic experiments, but also A/B testing, which is more like how do you collect business metrics and make sure you promote the version that is maximizing business metrics. So all those experiments are what we want to automate. We envision here, the scenario that we are envisioning is that your app goes through, or new versions of the app are going through Git. So Argo CD is reconciling and deploying those applications in from Git. But just looking at the labels that are supplied with those applications, that's what we are actually watching for, specific labels on the application resource objects. We can trigger these experiments, A/B testing and performance experiments automatically for those application resources. The experiments themselves do not go through Git. The experiments are just, in the cluster, and they're kind of transient resources, right? So when a new version comes up, the experiment automatically pops up. You can use the Iterate tooling to query results of the experiment. And when the new version is taken away, the experiment is cleaned up transparently, and it's happening in the cluster. That's the idea.
Okay. So an experiment, it mentions a Kubernetes job. Is that the like under the covers, is that technically what an experiment is? Is a essentially a Kubernetes job or script that executes, or can it be something else like just querying or
So it is it is a Kubernetes job, but there can be experiments where there are sort of repeated loops of the experiment. So over a period of time, you're collecting metrics for your different application versions, And over a period, you're checking whether the metrics are, satisfying. When you have a new version, is that new version maximizing profits or maximizing user engagement? New version of a machine learning model, for example, is that, leading to more clicks compared to an older version? So that's an example of A/B testing experiment. Yes, these experiments can be run using a job for one-shot experiments or a cron job for, these multi-loop iterative experiments.
Okay,
Maybe-
and then how I see the in the
Right.
diagram, a user can get reports on the experiment. So this when an experiment succeeds or fails or just provides information, what is the user? How does the user get these reports? And then like, does it affect? Is there any automation that happens like after, like if it's or is it just more for reporting?
Perhaps, Alan, maybe we can share some specific experiment pictures also
Yeah,
in the
sure.
yeah.
So you can take a look at.
Right. So this is a simple load testing experiment. So you're viewing a report using the CLI and you're, asserting conditions using the CLI. But in terms of further automation after the experiment finishes, one example is notifications, of course. So the experiment, as part of an experiment task, one of the tasks could be just notify. And you could say, notify Slack, notify some, GitHub Actions receiver. There are different, of course, you can build other notifiers also. So this is intended to trigger follow-up actions based on the results of the experiment. So there's a little summary as part of that notification data that right away tells you what happened in the experiment, but you can get more details also.
I see. Okay. Okay. See, and this is how a report would of an experiment would look like.
Yeah, this is a text report. There's also a little prettier HTML report also that you can view for, the metrics information. Yes.
Okay.
So
yeah,
one
go
thing
ahead.
we were hoping to achieve through this conversation was, first of all, we wanted to elicit your feedback and thoughts, comments. And second, we do want to come back to you with a working demo of this capability so that we can get perhaps even more relevant comments. And finally, any ideas you might have on how we can benefit the Argo CD community with these capabilities, we are very receptive and we would like to know more.
Is this implemented? This is implemented as a CRD that sits next to like an application or something. I'm just curious on how the
So this does not use a CRD. Actually, everything is Kubernetes native. That's jobs, cron jobs, the experiment under the covers. The configuration of the experiment job is through secrets, and the whole thing is packaged as Helm charts. So when you deploy the Helm chart, you're really deploying jobs whose configuration is in secrets, or cron jobs whose configuration is in secrets. That's how it works under the covers. Yeah.
Oh, okay. The reason I was asking because I thought if there was a custom resource that represented the experiment, just an idea that occurred to me while you're showing me this report was actually the we have capabilities in Argo CD itself to visualize CRs in any way that a user can code it in JavaScript. And this, I was thinking a nice improvement if you were to go this route is to actually embed the reports in the Argo CD UI using our UI extension mechanism. It wasn't, it was just an idea that I thought would be cool.
That's an interesting idea. And I mean, are there other ways to get the data into that Argo CD UI, or is it, what about Kubernetes native resources? Is there a way to
Actually, there's no reason you couldn't run an extension to visualize regular Kubernetes resources. The challenge will be because it's just a normal like deployment or job or something like you have to discern between just regular jobs that don't have like a report like this versus um, um, like a iterate job that would have this. And the benefits of using a CR is that you can customize the data that appears in the status and tailor it for the like then it's at that point it's really easy to just get information out of it. You wouldn't have to like run logs or other commands to get it. But it's why I asked if it was implemented as a CRD, because if it was, it would be a lot easier to surface.
Yes, I can see how it makes it easy from the Argo CD visualization perspective, but
Yeah.
part of the thinking here was that we have a CLI driven experimentation capability also, which is more imperative. So really anybody with namespace scoped privileges can launch experiments without having to install cluster scope CRD definitions. So that was part of the thinking that went behind this design. In fact, one of the very early versions of Iterate did use CRDs for doing experiments, but we kind of moved away from it specifically for this purpose.
Yeah.
But yes, we are happy to explore this Argo CD visualization capability and see how we can get the data in through some other extensions. Maybe the data can be in a secret, and maybe we can find a way to get that into your visualization.
And so as I understand, so Iterate is a CLI driven workflow where if to launch an experiment you execute a CLI to perform this experiment. Is that correct?
That's true, but that is kind of where we are kind of expanding the capabilities, you could say. So so right now you are using the CLI both to launch the experiments and to consume results out of the experiments. But we want to be able to do the experiments in a more automated fashion. And that's where and especially for GitOps users, that's where this new capability that Alan spoke about comes into picture. That will be more declarative launches of the experiment. So depending upon some labels that you mark up on the resources, the experiments are automatically instantiated or removed for that matter, or updated. So that's a more declarative flavor of running these experiments.
Right.
Of course, to consume results from the experiments, you still need a CLI and or some tooling. And that's the CLI will continue to provide that tooling. But the launch has now, it's become more than just imperative. You can do it in a more declarative manner.
Okay. Yeah, because it was leading to a question of how a user might integrate like iterates and experimentation as part of their process. So I guess if they're using, for example, just CI to kind of orchestrate their deployments, they could invoke the iterate CLI to say, okay, after I deploy, then kick off an experiment. The other thought I had was Argo CD itself can launch a job, which could as a post sync hook, and that job could be nothing but an iterate CLI invocation to launch an experiment as part of the deployment process. So just throwing out ideas that how people might get started, or how you might suggest people to integrate with Argo CD. Even
that's a very interesting thought. The post deployment hook using the iterate CLI, we never thought of it that way, but it's certainly that opens up. It's really the same functionality, but depending upon their CI/CD process and familiarity with tooling and the process they want to adopt, you are opening up lots of different ways in which the experiments can
be orchestrated.
It
could be a poor man's solution to the approach that you're it sounds like you're going to take about a more declarative thing. But if you wanted to have something working today, it's possible to just use a post sync hook to invoke iterate CLI.
Makes sense. Yep.
Okay, and any other questions for the Alan or Srinivas?
Okay, well, I hope next time I'll be able to bring a fully working demo and we can explore this in more depth.
Yeah, no, thanks for coming. So I'm going, in the interest of time, I'm going to actually suggest we table the 2.6 features for January. Michael, what do you think about that?
If we have anything for the remaining 5 seconds, then yeah, we should table it. If not, I can talk fast.
We have 5 minutes, so I think I'll leave it to, I wasn't sure how much you plan to talk about.
Oh,
But we also could use some content for next month. Yes.
Sure. I think we've also got other stuff we can talk about next month as well. I can show
Okay.
these like real quick, and if
Sure.
folks have questions, we can follow up offline.
Yeah.
Okay. Let me make sure I'm sharing the right window. I'll just share desktop too, that'll be fun. All right, so 23 new features in 2.6, which will be released in 12 days, at least the release candidate. First one I want to talk about, Leo and Blake worked on. So if you use create namespace sync option, there's now the ability to add metadata to the namespaces that are automatically created, both labels and annotations. So it ends up looking like this. This is a test I just ran. This namespace was automatically created by Argo CD and got these labels added. That one was pretty fast, but a lot of work went into getting it done. The next one is the most requested feature for Argo CD, which is the ability to use an external values file with an open source Helm chart. And because that creates 2 sources of truth, now we need to manage a cache for 2 sources of truth. So we went ahead and expanded the feature to allow basically just a list of sources for an application. So let me look at the demo app. App details, manifest, instead of a source field, we now have sources, which is a list. I've got 2. The first one is this example app. It just has a deployment and a service. The second is where I'm keeping my values file. So right now I've not connected these 2. So we have deployment with 1 replica, 1 pod came up for it. Now I'm going to connect these 2 using a special newly invented syntax. And it looks like this. I'm going to reference that other source and add values prod.yaml, which just happens to be where I'm holding the values file. And that values file is just this. It bumps the replica count up to do. So you're going to see me doing a bunch of hard refreshes because we're still working on the caching logic. But ideally, this would just happen automatically for you. So now you can see that replicas went to 2, so it's using that other values file. And I can sync that up. So that's first amazing thing, number 1. You can use a values file, for example, in a private internal repo and version it. And you can see the issues getting it to update, but we will have 2 pods. Yep. Second thing that this buys us is we can just add arbitrary additional sources to this list, and they'll be added to the application. So I'm going to have to use a release name so the so that the names don't conflict. But if I save this and do a hard refresh, I should see 2 additional services and deployments added, and they are. Not only can I add additional resources, I can override resources. So if the name in this second source of truth of a resource, the name, kind, group, everything was all the same, but I changed one thing about it, the resource from the second source would take preference and override the first. So if there's a Helm chart that you just want to change one thing about, now you can do that with arbitrary resource overrides. So this was, I didn't write this code. Ashita from Red Hat wrote this, so huge shout out to her, and that's the demo.
That's great. I mean, we've been talking about this for years. It's actually cool to see it in action.
Yeah.
So it's getting closer and closer to reality. Yeah, great work, Ashita. Okay. So it looks like we're out of time, and I don't think there was any other agenda items. So we'll call it a wrap. Thanks everyone for attending the December Argo CD and Rollouts community meeting, and I will see you actually in 2 weeks, probably for the workflows meeting, and then next month for the monthly CD Rollouts January meeting. Thanks everyone.
Thanks.